You thought 3D printing was easy because the machine does all the work? Well, not quite. One printer is fine. 2, still manageable, but once you're running 10 or more, suddenly your dream setup becomes a full-time job. Cleaning beds, restarting jobs, babysitting printers, maybe even getting up in the middle of the night to stay on schedule. And that's when it hits you. The printers aren't the bottleneck, you are. Unless your printers can run themselves. So, what if your FDM printers could actually work while you sleep? What if your entire print farm could run jobs, remove parts, clean itself and start again? No human in between? Automation isn't just about convenience, it's about maximizing uptime, reducing manual labor and scaling efficiently. In this video, we're diving into automated FDM print farms, what can be automated, what can't, and why most farms still rely on people. Automation in a print farm goes beyond remote start. It includes detecting when a print is done, removing the finished part, cleaning the bed, restarting the next job, assigning the right job to the right machine, and optionally, failure detection and print quality checks. FDM is the most common and the most automation-friendly 3D printing tech. At the entry level, you've got custom G-code scripts that cool the bed and push finished parts off using the printhead. Add an angled platform and a chute to direct the prints into bins, and you've got basic automated part removal. It works sometimes, but it's limited. Depending on the geometry and the material used, not every part comes off cleanly. If something sticks, you risk damaging the printer. And there's usually no feedback to confirm the part was actually ejected. More advanced systems go much further. Cosmic's Mira and Mosaic's array are full-fledged print farm solutions. They are specifically designed for autonomous FDM printing and combine multiple printers into a single production cell with robotic part removal and smart job queuing. The Mira swaps out the entire build plate, flexes it to remove parts, and puts it back all autonomously. The array uses a gantry to move beds between the printer and a shell system, prepping them for the next job. They also handle automated job distribution, matching print jobs to available printers based on material, nozzle diameter, and current load. This is a game changer when you're running varied jobs or working with tight deadlines. Some farms even integrate camera systems, sensors, and AI to detect under-extrusion, spaghetti, or other common failures, minimizing downtime and waste. And since there's less human handling, you'll also deal with fewer issues like oily fingerprints interfering with adhesion. Before you rush to automate your print farm, here's a reality check. Automation adds cost, complexity, and maintenance overhead. When something breaks mid-process, troubleshooting can be harder than just walking up to a printer. And steps like support removal, inspection, or occasional nozzle swaps still often require a human touch, at least for now. So, using soluble supports can make removing them a breeze and easier to automate. Also, not every print farm needs full automation. If you're only running a few machines or highly varied jobs, manual operation may still be faster and cheaper. So, why doesn't every 3D print farm automate their printers? Because it's possible, but not always practical. If you're printing 24/7 and scaling up, automation can seriously boost productivity. But it's not plug and play yet. As the tech keeps evolving though, fully autonomous production is getting closer. Until then, we'll keep things moving one print at a time. See you in the next video, and happy printing!